Hello viewers, welcome to my channel. Today we shall be looking at a very important topic in mathematics, which is surd. Surd is a mathematics topic for the senior secondary category. Those in SS1, SS2 and SS3 categories will find this topic very important, of which I'm going to make it as simple as possible. We'll start by taking note of some of the key points to note in solving questions regarding surd. So please pay attention to the end of this video so that you'll be able to get every bit of the details that has to do with calculations on surd. All right, so let's get started. Some key points to note, but before we get into that, let me explain briefly what this surd is all about. I do tell my students that surds are irrational numbers, but we're going to be discussing it in the context of roots, because there are various kinds of irrational numbers. Take, for example, pi. Pi, you know the value of pi, which is 22/7. Pi is an irrational number. You remember those kind of calculations you do whereby you press the number, say for example 22/7. When you punch this in your calculator, you have an endless number. You can't predict where the numbers will end. All right, so such numbers are referred to as irrational numbers. Then we are going to be talking about it in the context of roots, in the sense that when we have something of this nature, that is a root 9, can we say that root 9 is an irrational number? No, because root 9 can be determined. In this context, square root of 9 is 3, because 3 multiplied by 3 will give us what? 9. But when you have something like this, root 5, what do you think we are going to have here as an answer? Of course, we are not going to have a unit number here as an answer. When you point this in your calculator, you are going to have an endless digits of numbers. So in this context, root 9 is not a surd, but root 5 is a surd, because we can't determine this exactly. I hope this is quite clear. All right, so root 9 is not a surd because it is a rational number. Remember what I said, that surds are referred to as irrational numbers. Then we are discussing it in terms of what? Roots here, of which root 5 cannot be determined. You can't say that this number multiplied by this number will give us 5. But in this context, we can say that 3 multiplied by 3 will give us 9, of which we can now say the root of 9 is what? 3. But root of 5 cannot be determined. So therefore, this can be referred to as what? A surd. All right, so you can see the difference between rational and irrational numbers, of which I classify all the irrational numbers, and most especially those that has to do with roots, as what? Surd. We call them surd. All right, so let's now look at some of the key points to note in dissolving or resolving any issue that has to do with surd. Just pay attention to the end of this video. You will get to understand every bit of things that is concerned with what? Surd. We're going to be doing simplification of surd as well as rationalization of surd. So these are the key points for us to note here. Number 1 here, root A, I'll be using A to represent a number here. Root A plus root B. You can see that both of them are not of the same root. So we can't say that root A plus root B is equal to root A plus B put together. No, this symbol here means not equal to. So root A plus root B is not equal to root A plus B. Look at what we're talking about here. If you have root 2 plus root 3, you can't write it this way, 2 plus 3. That's exactly what we're talking about here. Because if we compare this in the context of algebraic terms, let's say this represents, root 2 represents x, and root 3 represents y. Can we bring the two of them together? Of course, we can bring them together. Why can't we bring them together? Because they are unlike terms. If we have it as x plus x, that's why we can bring them together to say 2x. But when you look at both of them here, they are unlike terms, so they can never come together. That's exactly what we're talking about in terms of the first point here to note. The second point is similar to this, just like replacing the plus sign with minus sign. So same thing still apply here. Now you can't write it together inside a box, as the case may be, unless if they have the same sort. Let's say we have sort A, we have sort B. If you have sort A, of which we're coming to that here. All right, so in this particular context now, they can never come together in terms of bringing them closer in one root. All right, so another one that we have to note here, but we can write it this way. We can say that root A plus root B is equal to root A plus root B, because there's nothing you can do about it, because both of them are unlike terms, just like representing root A again as X plus root B as Y. If you are being given a question like this and asked to simplify, of which the answer must be X plus Y. So the question is as good as the answer. The reason why we can't bring them together and maybe say XY is simply because both of them are not what? Like terms. They can only be brought together if they are like terms. Of the point is quite clear. Now, the next one, I have already explained this already. So when you have the same sort, say root A plus root A, both of them just like saying X plus X. So that will give us 2x in this context. So they can come together being that they have like sorts. All right, so in this context, root A plus root A will give us double root A, as we have it here. If I have root 3 plus root 3, what do you think is going to be our solution here? Root 3 plus root 3 will give us 2 root 3. So we are not going to be writing it in terms of bringing them inside, but we'll write it in this form. It has to look like this. I hope this is getting very interesting. By the time we're done explaining some of these key points, you will find the solutions of the simplification of surd quite easy. All right, so let's go further. The next one we have here is that of multiplication. Root A multiplied by root A can actually give us what? A. Somebody may be wondering, how do you have to get A here? All right, so we can put it this way. Root A multiplied by root A ordinarily supposed to give us root A times A. Remember, we can bring them together according to our rule as far as this one is concerned. So of which when we say A multiplied by A, we can bring them together in terms of multiplication, but in terms of addition or subtraction, we cannot bring them together because they are unlike terms. All right, so here we are going to be having it as root A to the power 2. Recall when I did something like this, I said root 9 is equal to 3, right? Why do I say so? Because I can equally say 3 multiplied by 3 to give me what? 9. So when I have this, okay, I want to explain how I got this A. As I have this A squared also means A multiplied by A. A multiplied by A will give us what? A squared. So for this reason, I can equally say that the square root of A squared will give us what? A. Just like the square root of 9 will give us what? 3. I hope this is getting interesting. All right, so that's exactly what we have to say on that particular key point. All right, so let's move to the next one. You now see why this is like this. So we can have something like this, root 3 multiplied by root 3, of which it will give us root 9, because we can bring them together in terms of multiplication. 3 times 3, that will be 9. So the square root of 9 is what? 3. So I can simply say root 3 times root 3 will give me 3. Just like I said, root A times root A will give me what? A. All right, so I hope this is very simple. All right, so let's now move to the next point. As we have it here, unlike this particular one, whereby we have different kinds of surd, but in terms of, you can bring them together in terms of their subtraction, addition or subtraction, but you can actually bring them together in terms of what? Multiplication, just like saying X multiplied by Y. X can multiply Y, and when we say X multiplied by Y, that will give us X, Y in terms of multiplication, but we can't say X plus Y is maybe XY. It doesn't make sense there. In terms of multiplication, they can come together, but in terms of addition, they can never come together, addition or subtraction, because they are unlike terms, so they cannot come together in this context. All right, so we can have it like this: root a times root a to give us, we can bring both of them together inside one root. That will now be a multiplied by b. That will give us root ab. So root a times root b can give us what? Root ab. Then in terms of division, once both of them are inside the root, we can separate them in this form. So these are some important key points to note as we go into the real question of simplification of surd. Now you pause and wait as we continue with some of the examples that we have here. Please don't forget to click on the subscribe button to support the channel as we continue to make mathematics very simple for everyone to understand. Now let's get started. Let's take some of these examples. Number one, we have number 1a, which is root 27, B, root 50, and C, root 250. All right, so likewise, we have number 2, have 3 root 75 minus root 12 plus root 108. Number 3 and others. So now let's start with number 1, the solution. Solution number 1a. Understanding these smaller ones will help us to be able to dissolve the longer questions. All right, so number 1a, here we have root 27. So what is our focus here? Because this is not a perfect square. Recall what I showed you when I was trying to explain the surd, the meaning of surd in terms of irrational numbers. If you recall, we said that when you have a number that is not a perfect square, then that particular root is what is surd. I used root 9, for example. Root 9 is determinable, of which root 9 is 3. But if I give you root 5, you can't determine root 5. When you punch it in your calculator, you are going to be having some funny numbers that is endless. All right, so that's exactly what we are talking about. Now, to solving this particular question, what we are going to do is to simplify the number that we have in the root to see whether if we can actually get a perfect square number inside this. Can we actually get a perfect square number here? Yes. Look at the idea. The idea is that in this particular surd 27, we should get two multiples of 27 whereby one of those multiples must be a perfect square. Recall, perfect square. How do we get perfect square? When you multiply a number to itself, it will give you a perfect square. For example, 1 multiplied by 1 is 1. 1 is a perfect square. 2 multiplied by 2 is 4. 4 is a perfect square. 3 multiplied by 3 is 9. 9 is a perfect square. 4 multiplied by 4 is 16. 16 is a perfect square. 5 multiplied by 5 is equal to 25. So any number that appears here, when you multiply a number to itself, is known as what? A perfect square. So such can be determined inside the square root. Now look at what I want us to do here as quickly as possible. What are the factors of 27 that one of them must be a perfect square? And when you multiply the two of them together, they will give us 27. We have various numbers that can give us 27. We have 27 multiplied by 1 will give us 27. Okay. Then we have another one that should be, that will be 3 multiplied by 9 will give us 27. Is there another number that can give us that? No. We can use this one now. This is what we're going to use. Because 9 is a perfect square, while this one is not a perfect square. So we are looking for the two factors of which one of them must be a perfect square to give us this. So I will take it this way. That will not be 9 multiplied by 3 will still provide us with the same thing as what? 27. So the idea here is that to simplify a particular number of surd, all you need to do is to find the two multiple of the numbers that can actually give us one perfect square out of the two of them. In this case now, we have 9 as a perfect square because 3 times 3 is 9. All right, so in this case now, we can simplify it by saying the square root of 9 is what? 3. 3 here is not a perfect square, so therefore we'll leave it inside the root. So therefore this becomes the solution to square root of what? 27. This is exactly what you are expected to do. That's the simplest form of root 27. Then let's go to that of B. We have sort 50 or root 50 as the case may be. So what do we do in this particular context? So we have to look for the two multiples of 50 that one of them must be a perfect square. What and what are we talking about? Somebody might suggest 5 multiplied by 10 as 50. But can these two multiples actually give us what we need? Remember, the condition we are given here is that one of the multiples must be a perfect square. Now the question is 5 a perfect square? No. Is 10 a perfect square? No, because there is no particular number you multiply to itself to give us 5, or there is no particular number that you multiply to itself to get what? 10. So therefore, none of them are perfect squares. So therefore, we are not going to make use of the two multiples. Now, suggest another set of numbers. And the number is going to be 25 multiplied by 2. Remember that 25 multiplied by 2 will give us 50, of which can we now suggest the one that is what? A perfect square. Of course, 25 is a perfect square. So the idea here is that one of the two multiples must be a perfect square. One of them must be a perfect square. So we can now resolve the question as follows. The square root of 25 is 5. Then 2 is not a perfect square. We'll leave it inside the root. So the answer is 5 root 2. That is for number 1B. Then number 1C, using the same method, 250. The two multiples here will be 25 multiplied by 10. 25 multiplied by 10 will give us 250. I hope this is quite clear. So how do we now resolve it finally? The final answer there will now be the square root of 25 is 5. Then 10 is not a perfect square, so we'll leave it inside. And you can simplify 10 further. So this is exactly how we resolve and simplify surds, as you can see on the board. So we're going to use the idea that we have developed here in solving number 2, number 3, and number 4. Now, let's go to number 2. You can give it a try after getting some of these simpler ones. Let's give number 2 a try. Pause the video and give it a try. Please don't forget to click on the subscribe button to continue to support the channel as we continue to make mathematics very simple for you. For the number 2 example, here we have 3 root 75 minus root 12 plus root 108. So how do we approach this one? We first of all simplify the individual surds, after which we'll now see whether if they have the same surd for us to be able to bring them together. Otherwise, we'll leave it that way. So let's get started. Here we have 3, then root 75. What are the two multiples of 75 that one of them must be a perfect square? Always take the highest of the perfect square number possible. All right, so from here, the highest number will be 25 multiplied by 3. If you are finding it difficult to locate the number you are going to be using, so you can do it this way to figure out the number that you are going to be using. 75. 3 can divide 75, and when 3 divides 75, it will give us 25. Then 5 can divide 25. 5 divide 25 will give us 5. And 5 divide 5 will give us 1. So we are taking the multiples here. So whenever you combine a number, whenever a number has a partner, the two of them can form a perfect square. So for that reason, I can combine 5 and 5 by saying 5 multiplied by 5 will give me 25. That will give us 25. Then we have 3 remaining here. So that's where we can now use 25 multiplied by 3. That's the maximum perfect square number we can achieve from 75. All right, so I hope this one is clear enough. Let's now conclude this. minus, so to simplify this one, can you guess what we're going to have here? That will be 4 multiplied by 3. Then for this particular one, guess the number that we're going to have there. Using the same method of figuring out the numbers that we're going to use, 108. Then when we say 2 divide 108 will give us 50. That will give us 54. Then 2 can still divide. 2 divide 54 will give us 27. 3, 2 can divide this one exactly. So 3 divide will give us 9. Then 3 divide again will give us 3. 3 divide will give us 1. These are the multiples that we'll be focusing on. Remember, when you can have a partner between 2-digit numbers, they can form what? A perfect square. So these two can form a perfect square of 4 here. Okay, then another one that can form a perfect square here is this and this, and that will give us 9. So when you look at the two that form a perfect square together, I bring both of them together here and leave this one aside. That will give me 4 multiplied by 9 will give me 36. So 36 multiplied by the remaining one here, which doesn't have a partner, will give me 108. So 36 multiplied by 3 will give us 108, of which 36 is a perfect square. So I'll put it this way: 36 multiplied by 3. I hope you understood how I was able to figure out the two multiples that will be used for this particular context. All right, so now let's go further. Let's go further. 25 is a perfect square, so it has to come out of the root. We now have it as 3. Square root of 25 will be 5. Coming out, we multiply the one that is already outside. 3 is not a perfect square, we'll leave it inside the root. Minus 4 is a perfect square. Square root of 4 is 2. We leave the one that is not a perfect square inside the root. Plus 36 is a perfect square. We write it as 6 root 3. Let's go further. 3 times 5 will give us 15 root 3. Then 2 root 3 plus 6 root 3. When you look at all of them, all the terms that we have here, this one has the root of 3, root of 3, root of 3. So we can say that all are like terms. So we can bring them together. It's just like having 15x minus 2x, assuming I'm using root 3 as x, plus 6x. So how do you simplify something like this? Of course, all of them are like terms, so we're going to be bringing them together. That will now be 15x minus 2x will give us 13x, and 13x plus 6x will give us 19x. I hope that is quite clear. Good. So let's focus on that. Using that same idea, 15 root 3 minus 2 root 3 will give us 13 root 3. Let me bring it down here. 13 root 3. Then plus 6 root 3. So bringing them further together, that will now be 13 plus 6 will give us 19. 19 root 3 becomes the final solution to this particular question. I hope this is quite clear. You can give number 3 a try, pause the video and give number 3 a try. Please don't forget to click on the subscribe button. All right, let's move on to the next question. Then for the number 3 solution, we'll quickly put it this way. 3, what are the multiples? That will be 9 multiplied by 5 minus 12 is already here. This one is already in its simplest form. You can simplify 5 further. 16. What are the simple multiples here? That will be 4 multiplied by 5. Because 4 multiplied by 5 will give us 20, of which one of them is a perfect square. Likewise, this one. So what do we do next? That will now be 3. Square root of 9 is 3. So you multiply it as it comes outside of the root. Then this one is not a perfect square. We'll leave it inside. Minus 12 root 5 plus 16. Then this one coming out, square root of 4 is 2 root 5. Wonderful. So what do we do next? That will now be 9 root 5 minus 12 root 5 plus this multiplied by this will give us 32 root 5. That is exactly what we have here. Okay, so what do we do next? We are to now simplify all together because they have like surds. As you can see here, root 5, 9 root 5, 12 root 5, minus 12 root 5 plus 32 root 5. So all are having root 5, so we can actually bring them together. We can't bring them together when they have different kinds of what roots. Assuming I have root 5 here, root 6 here, so they can't come together because they are unlike terms. But since both of them, all of them, have the same root, so they can come together in terms of what? Addition or subtraction. Now let's group them together. 9 minus 12, that's 9 root 5 minus 12 root 5 will give us, 9 minus 12 gives us minus 3, both of them root 5, plus 32 root 5. Both of them are still like surd. So what we're going to do to now get the answer finally, minus 3 plus 32, what do you think we're going to have there? What do you think we're going to have there? Of course, minus 3, that will give us 29. That will be positive 29 root 5. That is the solution to that. Minus 3 plus 32. Punch it in your calculator. Minus 3 plus 32. That will give us positive 29 root 5. That is the answer to number 3. Please give number 4 a try once again. Pause the video and give it a try. Let's now move to the next question. Then for the last example, here we have 1 over 2. Then to simplify this, what are the two factors here? That will be 16 multiplied by 2. 16 multiplied by 2 will give us 32, of which 16 is a perfect square. One of them must be a perfect square. Then for this, that will be 9 multiplied by 2. That will give us this, of which 9 is a perfect square. So root 2 is already in its simplest form. So to simplify further, this is a perfect square. We have 1 over 2. Then when this one comes out, it multiplied the one already there. That's 4. Root 16 is 4. Square root of 16 is 4. Then 2 is not a perfect square. We'll leave it inside the roots. Plus, then the root of this is 3. Root 2 plus root 2. 2 divide 4 will give us 2. So we are left with what? 2 root 2 plus 3 root 2 plus root 2. This one is just like saying 1 root 2. There's an invisible one here. So we now sum up our answer by saying 2, because all of them are having the same root, so they are the same like surd. So root 2 plus root 2, 2 plus 3 will give us 5. 5 plus 1, an invisible one here, that will give us what? 6. So we have it as 6 root 2 as our solution. I hope this is quite clear. Please don't forget to click on the subscribe button and pay attention to the videos that will be coming up next, and that will be on rationalization of surd. You will find that part one very interesting. Please don't forget to ask your question on the comment section, so that I'll be able to give attention to the ones you do not understand to make mathematics much easier for you. Please don't forget to click on the subscribe button to support the channel as we continue to make mathematics easy and simple for you. Thank you and have a great day ahead.